Today we are going to look at review the mole-to-mole and stoichiometry concepts. The first conversion, there's 4 conversion types, remember: a mole-to-mole, mole-to-mass, mass-to-mole, and mass-to-mass. So we're going to review those 4 conversion types. The first one is mole-to-mole. So if you are given, let's say you're given moles of A, and you want to convert that into moles of B. The conversion factor that we're going to need to use is the mole ratio. You will need a balanced equation in order to do this. And so if we are given mole of A, this unit needs to cancel out, so we need mole of A on the bottom, and we'll have moles of B on the top. Now remember, these numbers come from the coefficients, and the only way that you can get convert from one compound to the other is if you're in the units of moles. So you're going to convert from moles of A into moles of B. So let's try an example problem. Aluminum reacts with oxygen to give aluminum oxide. Is that equation balanced? See, we have 4 aluminums, we have 6 oxygens and 6 oxygens. So yes, it is balanced. So if you have 6.3 moles of aluminum, how many moles of oxygen are needed for the complete reaction? So we are given 6.3 moles. So we're given the units of moles, and they're asking for moles. So this is a mole-to-mole reaction or problem. So we have 6.3 moles of aluminum. So the units on the bottom, so that we get our units to cancel out, has to be moles of aluminum, and on top it will have to be moles of, we're asking for oxygen, so we want oxygen here. So our numbers from the balanced equation, we have 4 aluminums, 3 oxygens. So we need 4 aluminums and 3 oxygens. And when you take your calculator, you're going to take 6.3 times 3 and then divide by 4. And you should get an answer of 4.73 moles of oxygen. Very good. So on to our next type of problem, mole to mass. This is if we're given moles of A, and we're going to convert that into grams of B. So the conversion factors that we're going to use, first we're going to use the mole ratio again. Going to turn moles of A into moles of B, and then we will use the molar mass in order to change grams or moles of B into grams of B. So let's say we're given a certain amount of moles of A. Use our mole ratio. Mole of A has to go on the bottom. And remember, the only time we can go from one compound to the other is if we're in moles, so we can convert mole to mole. So we have moles of B here. And this is, these numbers come from the coefficients again. And these units cancel out. So now the units down here have to be moles of B, because we aren't to grams of B yet, we have one more step. And the units up here, we can go, when we're in the moles of B already, we can go straight from moles to grams. Now whenever you convert moles to grams, you're looking up this mass from the periodic table, and that mass is always the mass of 1 mole of B, so we can already put a number here of 1. So there's how we're going to do it. So let's try an example problem. Several brands of antacid tablets use aluminum hydroxide to neutralize that excess acid. Gives us an equation here. Is it balanced? Let's check. We have 1 aluminum, 1 aluminum. Okay. We have 3 oxygens, and we have 3 oxygens over here. And then we have 3 plus 3 hydrogens gives us 6 hydrogens, and we have 6 hydrogens here. and then 3 chlorines and 3 chlorines, so it is balanced. So what quantity of hydrochloric acid in grams, so our final answer should be in grams, can a tablet with 0.53 moles of aluminum hydroxide consume? So we're given moles, we want the answer in grams, so this is a mole to mass. So we have 0.53 moles of aluminum hydroxide, OH3. And remember, our units have to cancel, so we're going to put moles of aluminum hydroxide on the bottom. And we can go from mole to mole to the HCl. So we're going to have moles of HCl on the bottom. And if we look at our coefficients, we have 3 HCl to 1 aluminum hydroxide, so we have 3 to 1. These units cancel out. And again, we're going to be able to convert moles of hydrochloric acid into grams of hydrochloric acid. And remember, when we do that, we can have 1 mole. The mass of hydrochloric acid would be 35.45 plus 1. So that is 36.45. Units cancel. We're left in units of grams of HCl, which is what they want. So we're going to take 0.53 times 3 times 36.45, and you can divide by 1, but we don't really need to do that. So our answer is 57.96 grams of hydrochloric acid. Very good. Next problem is mass to mole. In this case, it's just kind of backwards of that last problem we did. We're given grams of A this time, and we're going into moles of B. So we're going to first change grams into moles of A using our molar mass. Then we will use our mole ratio to change moles of A into moles of B. So again, we have 2 steps here, just opposite of what we just did. So if we have grams of A right here, we're going to need grams of A on the bottom to cancel our units. And remember, when we go grams, we can go straight to moles as long as it's the same compound. So we can keep compound A. And whenever we go from grams to mole or mole to gram, it's always 1 mole. And this number you would look up on the periodic table. Okay, so our units here cancel. Left with mole A, but they want the answer in mole B, so we're going to have mole A on the bottom here to cancel out. And we can go mole to mole to get mole B on the top here. And those 2 numbers come from the coefficient. Very good. So let's try this problem. Suppose 16.04 grams of methane is burned in oxygen. How many moles of oxygen are consumed? So they're giving us a number in grams, and they're asking how many moles. So it is a mass to mole problem. Is this balanced? Let's check. 1 carbon, 1 carbon, 4 hydrogens, 4 hydrogens, and then 4 oxygens. And we have 2 oxygens here plus these 2 oxygens, so we do have 4. So it is balanced. So let's start with 16.04 grams of methane. Remember, we can't go grams of methane straight to grams of oxygen, so we're going to have to convert to moles first. So 1 mole of methane is going to equal the mass of methane. So carbon is 12 plus 4 hydrogens, each hydrogen is 1. So that would be 16 grams. Our units here cancel out. Now we have to have moles of methane on the bottom, and we can go from moles of methane into moles of oxygen since we're in the units of moles. And the coefficients here, we have a 1 and a 2, so it's a 2 to 1 ratio. And these units cancel out. They're asking for moles. We are in moles of oxygen, so we can convert this now. We're going to have 16.04 times 2, and then divide by 16. And you are going to get 2. Now, if you didn't want to use your calculator on that, you should be able to see 16.04 divided by 16 is basically 1. So you multiply by 2, you'll get 2. And the last problem. Let's see, it's a mass-to-mass conversion. So we are going to go from grams of A into grams of B. Is the pin working? Grams of A into grams of B. Now this one is going to be the longest of the 4. And the first conversion factor we're going to do is we're going to have to convert grams to moles using our molar mass. Then we can go mass or mole to mole of A to B using our mole ratio. But they want the answer in grams, so we're going to have to change the moles back into grams. Excuse me. Using our molar mass. So you can see we're going to have 3 steps here. So if we start with grams of A, okay, we're going to have grams of A on the bottom and convert that into moles. We cannot go gram to A, gram to B. We have to be in moles in order to convert from one compound to the other. And remember, whenever we go mass to grams, it's always the mass of 1 mole. So that number here comes from the periodic table. These units cancel. So now in order to cancel out moles of A, we have to have moles of A on the bottom. And we can go moles of A and moles of B since we're in the mole unit. This number and this number. And those come from the coefficients. And the last conversion we have, oh, these cancel out here. We need moles of B here. So the question is asking for grams. We aren't quite to grams. Grams of B, this number comes from the periodic table. And remember, whenever we're finding the mass of a compound, it's always a 1 mole of the compound. So there is our generic conversion. So let's do a specific problem here. Like many metals, aluminum reacts with a halogen to give a metal halide. So we have this equation as a balance. Let's check. 2 aluminums, 2 aluminums. We have 6 bromine, 6 bromine. So it is balanced. So what quantity of bromine in grams, so they want the answer in grams, is required for a complete reaction with 2.56 grams, again, of aluminum. So we start with our 2.56 grams of aluminum. We can convert grams to moles. 1 mole of aluminum is, I'm on my periodic table, it is 26.98 grams. 26.98 grams of aluminum. So grams of aluminum cancel. So now we need moles of aluminum on the bottom in order to cancel that unit, and we can go mole to mole, Br2, and our coefficients are 2 to 3, 2 and a 3 here. So moles of aluminum cancel. And last step, we still need to get to grams. So we need moles of bromine on the bottom and grams of bromine on top. Remember, we go moles to grams. It's always 1 mole. Bromine's mass is 79.9, but is Br2, so we need 79.9 times 2, which is 159.8. 159.8. There we go. So these units cancel right here. We're left with grams of bromine, which is what they're asking for. So we have the right units. Let's calculate this. We'll have 2.56 times 3 times 159.8 8 equals, and then we'll divide by 26.98 and divide also by 2. So we will get an answer of 22.74 grams of bromine. And that's it. So you guys can review this and make sure you study the sheet here.